Hey, welcome back to the garage. Today I thought I'd do a CNC project, go through all the steps from designing something in Fusion 360 all the way through cutting it out on the CNC router, just to give a fairly introductory version, not assuming people know much about Fusion 360 or CAM or cutting things out on the CNC router. So hopefully this will be a useful getting started guide. So for a first project, I thought this would be good. I made a few of these early on when I got my CNC router table. I want to make a few changes to the design, so I thought this would be a perfect opportunity to do a full video. But what these are, it's just a simple hold down clamp for holding parts down onto the table when cutting, basically for holding plywood parts down primarily. It's simply made out of some 3/4 inch plywood, a slot in there that a bolt can fit in, and of course it's recessed so the head of the bolt fits down in it, makes it fairly low profile, reduces the chances of hitting that with the bit, so that hopefully hopefully you don't damage bits by hitting the bolt. The advantage of making the part out of plywood is, of course, odds are you're gonna mess up. You're gonna put these in the path of the cutter occasionally, but since it's plywood, you shouldn't damage anything other than the part itself, and you can always make more. So the way they work is, of course, you can bolt it down with the slot. There's a little bit of a notch underneath that can both hold down and push against the part that you're clamping down. So if we have just our stock that we're machining, the lip goes over it, and these are 8mm bolts. You can, that's the size of the threaded inserts I have in my table. So you can get these as like 1/4 inch or 8mm. There's various sizes available. That'll hold it so it'll keep it from coming up, of course. It does a really good job of keeping it from pushing back towards it. It doesn't do a great job, as you can see. You can pull it out from underneath. But what works well is if you have these on all 4 sides, it locks the piece in pretty well. So these are not overly complex. However, and part of the reason I chose these is because we need to do operations on both sides. We have the recess that's on this side, so obviously you need to cut with that facing upwards. But we also have this notch on the underside, so it does add the extra little trick of flipping the part over and making sure things line up. So I thought this would be a good getting started. So let's go to the computer and I'll show you how we design this in Fusion 360. So here we are in Fusion 360, ready to design our part. Now there's a couple things that I always like to do before I start drawing anything. So we're in a brand new unopened or untitled project. The first thing I do is I go ahead and save it. And so we'll call this hold down clamp. The reason you want to do that is once it's been saved once, Fusion 360 will auto save it from time to time. So if your computer crashes or power goes out, you don't lose everything because it'll save it from time to time. The other thing I do is I set up a couple of named parameters for the design. What this is, it's ways to define certain parameters and give them a name so that you can change them later. So why would we want to do that? So first of all, to do that, you go Modify, Change Parameters, and under here next to New User Parameters, we can click plus. One thing I typically do if I'm making anything out of plywood is I'll create a parameter called ply, and in this case we're using 3/4 inch plywood, so I'm going to do 0.75. Now the problem is 3/4 inch plywood is rarely actually 3/4 of an inch. It's usually undersized a little bit, so what we can do is for now we can just define it as 0.75 inches, and then when we actually find a piece of plywood we want to cut this out of, we'll measure the actual thickness and change this. And by using these named parameters, it can automatically adjust the diagram rather than having to go through the part and find every place where we did the thickness and changing it. So we'll click OK there. The other thing I want to do is I'm going to define a parameter called length. The ones I did before were 6 inches, and we'll use that for a starting point here, but I'd like to make a few that are longer, a few that are shorter. So if we just change this parameter later on, we could make an 8-inch one or a 12-inch one even, whatever we want to do. And we simply can, any place in the diagram where we reference the parameter length, it'll be whatever we have this set to. So we've got that. Now we can actually start drawing. All drawings or all parts in Fusion 360, you can do things that that start out as 3D, but normally what you do is you create a 2D sketch and you extrude that into a 3D part. So what we'll do here is we'll go up to sketch and create a new sketch. And what it's doing now is it's asking what plane do we want this on. So we could have it like on this plane, which is essentially the floor of this space, or on this plane, which is one wall, this plane, which is another wall. Doesn't really matter at this point which one we put it on. So I'm just going to put it here on this plane. So we're looking at it from the top. And we can start sketching here. So the basic body, we'll just start with a simple rectangle. So I'm going to do a 2-point rectangle. And I'm just going to quickly make a rectangle, not even paying any attention to the size. So right now we've got just our rough rectangle. We know we want the length to be that length parameter that we talked about, that we set in the user parameters. And for the width, let's say we want it to be 2 inches. So from here to here, we want this to be 2 inches. So we need to do what's called a dimension. This is, I honestly don't even know where this is in the menus because it's something you use so often that I just always use the keyboard shortcut, which is D. So you press D on the keyboard. You'll note the mouse changed, the icon next to the mouse rather changed to a dimensioning symbol. And what we want is we want to set the dimension between this line and this line. So if we click on one of the lines, first it thinks we're trying to define the length of that line. But if, before we click anything else, if we click on the other line, now it realizes that we want to define the distance between these two. So right now, it's 1.2 inches is just the random width that I drew it to when I dragged the rectangle out. We want to set that to 2 inches. Now, from here to here, we can do the same thing. We're still in dimension mode based on the icon next to the mouse. So let's click on this side and then this side. And on this, we could just enter 6. However, we want to make use of that parameter that we created so that later on, if we want to change this, we don't have to go into the diagram and change where we entered the parameter. What we can do is we can actually enter that named parameter. So if we enter length here, you'll see that it sets it to 6 inches, but it's fx6, meaning it's a function that the result of that function is 6. In this case, it's a very simple function of just a single parameter, but later on we can change that parameter to update this. Now we want to round off these corners a little bit. We don't want this to be just a simple block. Now, if you noticed in the diagram, or the part that I had earlier that I had done before, I had rounded off the corners in the back and kind of created angles at the front. Now, both of these things you could do after it was in 3D, you've extruded this into a 3D part, or you can do it as part of the two-dimensional sketch. So what I'm going to do is, to start with, I'm going to do this end of it in the 2D sketch, and we'll deal with the other end when after we've extruded it to 3D, so you can see both methods. So we just want some simple rounded corners here. The easiest way to do that is to just create a couple of circles. So let's go up here, sketch, circle, center diameter circle. And we're going to put, right now I'm not going to pay too much attention to the exact size or where they are. I'm just going to draw a couple random circles. And let's say we want this curve here to be a 1/2 inch radius. So to do that, what we want to define this circle, I'm going to go back into dimension mode. So I'm hitting D on the keyboard, clicking on this circle, and we want a 1/2 inch radius, which is a 1 inch diameter. So I'm going to enter 1 there, and I'm going to do the same thing on this one. So now I've got these curves the right size, but obviously not in the right location. Now you might be tempted to just select the circle and drag it, to where it looks about right, and that may work, but it's not really the right way to do it. As you zoom way in here, on this one I got it pretty close, but you zoom all the way in, you see it's not actually right on that line. It's just really close. So what we want to do is we want to say this is exactly tangent to these two lines. So the way you do that, rather than just, I'm going to drag this away to make it a little more obvious. The way you do that is you apply constraints. Over here on our sketch menu, you see down here we have various constraints. First of all, let's make sure we don't have anything selected. So I hit escape. And one of these constraints is a tangent constraint. So let's click on it. Then when we click on the circle and then the line, you'll see that it added this little tangent constraint marker and lined it up so that it's touching this side. And we can do the same thing up here. And now we know that this portion of the arc here is exactly the curve we want. So let's do that on this one as well. Make it tangent to both sides. And now we have our curve as we want it. So now let's work on the slot that's going to go in the middle. We don't want the slot to go all the way to the end. We just want it to go, let's say, 3/4 of an inch from the end, from both ends. So let's say that we want to make sure the slot ends 3/4 inches short of each side. In order to do that, we really need something to line that up to. So that is what we have, this concept of construction line. So I'm going to create a line. Now I don't want an actual line, because a normal line would be part of the part. I just want a construction line, which is something you use just to help line up other features of the sketch. So in the sketch palette, we have this option called construction. I'm going to select that, and now I'm just going to draw a line straight across here. And I didn't pay any attention to how long it was, but I did. It automatically did a perpendicular constraint here, and we'll talk more about perpendicular constraints a little bit later. But this line is, tied to both endpoints are tied to these opposite sides of the part, and it is perpendicular, but it's just a random width from the end. And we're going to do the same thing over here. Create another line. We want both of these to be 3/4 of an inch from the end. So once again, we hit D to go back into dimension mode. Select this line. Also then select this line. And we can do 0.75. And that gives us this dotted line here that's right where we want it. Now, this is getting a little cluttered with these circles and these lines all kind of overlapping here. All we really care about for these circles is this portion of the arc that cuts off this corner. So what we can do is we can trim out some of this. And this is another one that you use often enough that it's easy to remember. The keyboard shortcut for trim is just T. Change the icon next to the mouse again. And we can click on this, and what it does is, see how it turns it red. It's any place this arc intersects some other line, it assumes that's what you want to trim. So right there, it's trimming everything up until it intersects. And same thing here. So we're going to get rid of all the bits that we don't care about. So now it looks like there's more of the arc, but this is actually just part of the dimension notation here. Is it's showing that this is actually the diameter of an arc that would be here if there was still an arc there. But we've cleaned up a lot of that. So now I'm going to go back into dimension mode and set this one to be 3/4 of an inch from this side. And so now we know we want the slot from here to here. We also need to know exactly what is the midpoint. We want our slot directly in the middle, of course. So let's go into Sketch and create another line. Now on this one, notice how, as I move my mouse along here, when I get to the middle, we see that triangle. That is adding a midpoint constraint. So when I click here, I'm creating a line that's tied to the midpoint of this other line. And as I go over here, I get another one when I reach this side. So I'm connecting this line as directly to the midpoints of the other lines, which means I'm exactly in the middle. So we can line up our slot directly on that. So let's actually draw the slot now. And the way I'm going to do that is I'm going to create two circles and then connect them in lines. So let's go into Sketch, Circle, Center Diameter Circle. Now we're still in construction mode, just like we did these lines in construction mode. If I draw a circle right now, you'll see it's a dotted line again, which is not actually what we want. So I'm going to Control Z, get rid of that. Let's go Sketch, Circle, Center Diameter Circle, but I'm going to uncheck this construction icon here. So now when I draw a circle, I get a normal solid line. And so let's just create two circles. Now notice that I didn't even draw them on the part, I just drew them in a random space. We're going to line them up using constructions. So first of all, we need to set the size of these. So of course that's D for dimension. And on my system, or on my table, I use 8mm bolts for this. The rest of my diagram is all in inches, but it'll do the conversion for you. You know, if I enter 8, of course, it's going to give me an 8-inch circle, which is clearly not what I want. So if we double click on that again, we can change that. What we really want is 8mm. So if we do 8mm, you'll see that it did the conversion for us to 0.315. So, you know, you don't even have to worry about converting between inches and metric. You can simply specify the size and it'll do it for you. So now let's get these aligned where we want. So we need to do two separate constraints on these. We want them to be coincident with this line, meaning the center of this is along this line, and we want them to be tangent to this line, because this is where we want our slot to end. So first of all, to make it coincident, over here in constraints, we have this coincident constraint. Click on that. Now click on the center of the circle, and then on the line. And you'll see it put it right there on the line like we want. Same thing with this one. So now, if I hit Escape, and I select one of these, and I try to drag it, you see it lets me drag it left and right, but not up and down. That's because we've said, hey, this has to be on this line. It's not allowed to be anyplace else. But we haven't said anything. We haven't set any constraints about where on the line. So now, let's, just like we did earlier, we go tangent between the circle and the line. And same thing over here. So now we have the endpoints of our slot right where we want them. So now let's connect these two circles. So let's sketch a line. And once again, I'm going to draw it completely off the part, and we'll use constraints to line it up. So now notice how since I didn't end this intersecting with any line, it thinks I want to continue. By default, it tries to do a multi-segment line. But if I come down here to this little check mark, that means I'm done with that line, and you don't need to, or you don't want to do any additional segments. We'll do the same thing over here. You can also hit Escape. So on this one, I'll just hit Escape, and it did the same thing. So now we want these lines to be just touching these circles. So, of course, we've got our tangent constraint. So if we do that and say tangent to there, notice how it's not quite what you would think. You'd say, well, that's not a tangent. It actually is, because if you were to extend this line out infinitely, it would be touching this circle. So where it is in space, you know, the angle is pointing would go right by it, but of course we want it touching, and touching means we need the coincident constraint. So we'll also do that, the endpoint and the circle, and that end of the line is where we want. We also want this end to be coincident here, and notice how that's still not quite where we want it. It's because we also need that to be tangent. So now we have a line connecting these two that's going to be the side of our slot, and we'll do the same thing with this line. our tangent constraints, and we'll add our coincident constraints. And there is our slot. Okay, so for now, that's all we want on this diagram. So or on this sketch rather. So let's do a stop sketch. And you see here under sketches, we have this new sketch called Sketch 1. I like to rename my sketches. So if you click on it and rename it, we can call this, this is basically the part outline, for lack of a better name. Once you have several sketches, it's handy to have the names so when you need to go back and edit them, it makes it a little bit easier. So we have a two-dimensional sketch. We want to turn this into a full three-dimensional part. So to do that, we go Modify, press Pull, and we select the face that we want to extrude. So there, just selecting this anywhere inside here, notice how that filled in all the areas that are bounded by the solid lines, but just ignored the dotted lines, because the dotted lines are just construction lines. Now we have this arrow. We could use it. We could pull it up, pull it back down if we wanted to go the other direction, and to a random length. Or we could type in a value. But what we really want to do here is this is going to be the thickness of the plywood. So we want to make use of that named parameter ply, and that will set the thickness to that 0.75 plywood. So when we decide we're going to cut this out of a slightly thinner piece of plywood, we can change that and it'll change how much that extrusion was pulled out. So now we have the basic rough shape of the part. So earlier I mentioned when we did these rounded corners, we did that as part of the sketch, but we also could have done that here in the by modifying the 3D part. So on this end, I'm actually going to modify this do something similar to what we did here, but in 3D. So in 3D, what we want to do is we want to create a fillet, which is just a rounded corner. So if we go Modify, Fillet, now it's going to ask us for what edges we want to create the fillet on. So we select this edge and this edge, and it's similar to the press pull. We get these arrows. We could push it in manually and pull it out manually. But what I want to do on this one is I just want to make this a rounded corner. We know that this is 2 inches apart, so if we create a radius of 1 inch, you'll see that we get a nice rounded nose on it. So we're going to just enter that, hit return, and we have the rounded end of it. Okay, so now let's work on the countersunk area that we wanted to do around here. We wanted to be able to recess the head of the bolt down into the part a little bit. So in order to do that, we need to create another sketch to show the outline of that countersunk area. So to do that, we need to create a new sketch, create sketch, and we're going to draw this sketch on the plane of the top of the part here. So we'll select that face. And now if we hide the body here, you can see that there's nothing on this sketch yet. So we need to actually transfer some of the dimensions of what we already have onto this sketch. So if we hit P for project, we can select a few things we want to make sure show up in the sketch. We want to make sure this whole slot shows up. So I'm going to select this arc, these two ends, and this arc. Click OK, and now if we hide the three-dimensional body, you can see that we have those parts. As I hover over it, it shows the outline of the body, but as far as what's actually on the sketch, it's just that inner part there, that inner slot. So what we want to do is we want to create another, essentially another slot just on top of that. So we're going to do a couple different circles. It's going to be very similar to what we did before. On this one, I want this to be large enough so I can get a socket onto the bolt, and I've measured that out to be 0.7 inches. So we'll D for dimension, 0.7 on each of these. Now, I want these circles to be directly on top of the center of this arc. So if we do coincident, click on the center of this and the center of this, that'll line that one up, and the same thing for this one. And the rest of it is just like we did earlier. We're going to create a couple lines. We're going to make them coincident with the circles. And we're going to make them tangent to the circle. Now this happens sometimes. It tries to guess exactly where you want it. There's a couple different possibilities here, because that is still tangent to both of them, but that's clearly not what we want. So if we hit escape, zoom in here, click on this tangency, delete that constraint. Now we can grab onto this, and we still have the coincident constraint, so we've got to be somewhere on it. And it's going to snap in. When we create the constraint, it's going to do whatever is closest to where it is now. So now, if we hit escape, go tangent between that and that, that's what we wanted. And I'm going to do the same thing on this other line. And there we have the outline of the slot that we want, so we can stop sketch. Show the three-dimensional body again, and now what we want to do is we want to do another push-pull, just like we did when we did the extrude. If we do push-pull and push down into the part, it'll cut that out. Now, since there's all these partial segments there that I didn't trim out, we need to select multiple faces, but the same thing applies. So what we want to do is we want to go down into it. Now we could do something like -0.5 to go half of an inch in. And you see that that is cutting down into it half of an inch. What I want to do though is I want to go 1/3 of the thickness of the part into it. So our thickness is ply. So if we do negative ply divided by 3, we can do a formula like that. And you'll see that that cut our recess in 1/3 of the way in. So now we're nearly done. The last thing we need to do is on the bottom here, we wanted to create a little bit of a notch, a little lip for it to sit down over what it's clamping on. To do that, we need to draw a sketch that gives us a line across here that we can push down in. So once again, we want to create a new sketch right here. We want to project a little bit of geometry. We want that curve on there, and let's do that edge, that curve, and that edge as well. That should give us enough to see what we need. Turn off the three-dimensional body, and so now we need a line, and on this one I'm going to just let it create the coincident construction right there. Also, right there, it's going parallel. You know what? I'm actually going to purposefully make it not parallel and do it kind of at an angle there, because I want to make sure the constraint is what I define. Sometimes the automatic constraints that it chooses are not quite what you want, and it gets a little confusing. The automatic constraints are great. It speeds things up, but sometimes it causes a little more confusion than it's worth. So now we need this line to go straight across, meaning this line needs to be perpendicular to this line. So we have a perpendicular constraint. We can click on this line and what we want it perpendicular to, and that lines up straight across there. Now we can still move it. We can move it anywhere along here. It's going to stay perpendicular. It's going to stay touching here. But we haven't defined where we want it. Now you could just drag it and drop it where you think you want it, but you're still better off actually defining exactly where you want this. And what I want to do is I want to do about 3/4 of an inch from the end, or sorry, about 1/2 an inch from the end. I mean, it's earlier we defined this as being 3/4 of an inch from the front of this, but we can't really define anything based on this, because you can't. If we go dimension and click on this and then click on this arc, it actually Notice how that is doing a distance from the center of the arc to the line, which isn't what we want. We want from the end of the arc. So let's create another construction line. Turn on the construction. We want to go across here. Oh, somehow I changed my wrong line to be construction. I'm not sure how I managed that, but that's a useful thing. So actually I meant for this one to not, this new one to be construction, and somehow I accidentally changed this one. Easy to do. You use this a lot, and that it's another useful keyboard shortcut. So if we select this line and press X, that toggles between construction and normal line. So that one is now a normal line. I'm going to click on this one and press X, and it's a construction line. So what I'm going to do is I want this line, actually back out. We want to go coincident between, not coincident, tangent. Tangent's what we want. Between this and this. So now we have something we can dimension from. I can hit D, and from here to here, dimension from this line to this line. I want that to be a 1/4 inch, because I know that this is 3/4 of an inch from here. That gives me a 1/2 inch lip. So now we have this semicircle portion defined here that we can use that to cut our little notch. So we can stop sketch, turn on the view of the 3D body again, and what I'm going to do is modify, push pull. I'm going to do this the same way I did to cut that recess in the top. We're going to select what we want and go negative pi divided by 3, so we go 1/3 of the way into it again. And that is our part. We've got our recess, we've got our little notch, and everything is parameterized. So just to demonstrate those parameters, now that we've got the full thing written, or the full thing drawn out, let's say we want one twice as long. Well, let's make one 12 inches long. So we go change parameters, and we change this length to 12 inches. And you see we have a much longer one. And if we want a shorter one, same thing. Say we want just a 4-inch part. Allows us to quickly and easily change that, and we can change the thickness for the plywood, and we don't have to redraw anything. As long as you've used that parameter properly, it will resize things. So next thing from this is we will actually do the cam to generate the toolpaths, and that will be in part 2 of the video series.